All right, so to verify axiom 4 of the inner, to show that this inner product is in fact an inner product, we have to show that for any vector in R2, the dot product of that vector with itself is positive or 0. So we have to show this in general again. And so we're going to see that for this product here, V1, V2, product with another V1, V2, gives us V1 times V1, that's V1 squared, plus twice, right, that 2 comes from the definition, V2 times V2, that's V2 squared. And so since both of these are squared real numbers, you note that this product will always be greater or equal to 0. It's only 0 if both V1 and V2 are equal to 0. So this is greater or equal to 0, and then we also have to say that if the product with itself is 0, that can only happen if the vector itself is 0. So this V dotted with itself, we found that it's equal to V1 squared plus 2V2 squared. The only way for this to equal 0, this happens if and only if both V1 and V2 equal 0. And so the vector itself is, the 0 vector. So I want to mention that at Brookdale in Calc 3, we use this notation to represent the vector 1, 2. But in linear algebra, we use this notation to represent an inner product. So the pointy brackets are reserved for inner product. So we showed here that all 4 axioms hold, right? So we showed that all 4 axioms hold for this particular inner product. And so we can conclude, since all 4 inner product axioms hold, the product UV defined the way it was defined, 2U2 V2, is an inner product. Now, to show that a different inner product, let's now define our product as the same thing but with minus, right? So we can define it as U1 V1 minus 2 U2 V2. Show that this is not an inner product. Just like with vector spaces, it is enough to show that one of the axioms fails for numbers. So we need to give a counterexample. We need to give an example of vectors that make one axiom fail. So we must show that one axiom fails and the numbers are okay. So the axiom that's going to fail is the last one. This inner product is not always positive. For example, for the vector given by 1, 2, the product of V with itself, I wrote it that way. The product of V with itself gives you the product of 1, 2 with 1, 2. According to this definition, I have to multiply the first 2 components, that's 1 times 1, minus I have to bring down this negative, this 2 over here, and multiply the second components together. 2 times 2 is 4. So then this becomes 1 minus 8, which is negative 7, which is not greater or equal to 0. It's less than 0. So because axiom 4 fails, this is not an inner product space. Now, you can go ahead and do the following problems after you watch this video. From your homework, I think you are prepared to do 1, 3, 7, and 17. These have actual numbers to plug in. So hopefully what I showed you will help you understand that you have numbers there that multiply into your inner product and you're not using the regular dot product. And number 25, you have to run through proving all 4 axioms hold. And number 33, you have to disprove it. So it's like this example. Number 3, you will have to show a counterexample. You showed that it doesn't form an inner product space. I will make another video a little bit later showing you how to perform some of the more complicated computations in this homework section.